Hello everyone, thank you for joining us in this session of Spokane Public Schools Keeps Learning series for mathematics. Today's lesson is for students in grade 3, but you are all welcome to join in. My name is Kelsey Shadow and I'm a third grade teacher at Cooper Elementary School in Spokane Public Schools. I will be your teacher for today and I'm glad that you are participating. If you haven't seen any of our other lessons, feel free to go back and rewatch on KSPS's website. Today we will be learning all about area. We will begin with quadrilaterals and move into some irregular shapes. For today's lesson, you will need something to solve your thinking on. Now, whether it's a piece of paper with a pen or a piece of paper with a pencil, I need you to go ahead and go grab those supplies and join us back here. I'll give you a moment to go grab your supplies. Let's go ahead and begin. Now, before we move on to talk about area, we all need to know what area is. Area is the total number of square units needed to cover a two-dimensional surface. So sometimes we'll see it divided into a grid-like sections of little small squares. Other times we won't. Now, for today, we're going to stick to working with quadrilaterals or shapes that are irregular but still have right corners. That way we can divide them into quadrilaterals. I know some of you are wondering, when would we ever use area? Area is used a lot in our everyday lives. It is used to measure how much flooring, so carpet or tile a place needs, how much grass or soil a yard needs, how much paint does a wall need. It is also used for planning spaces. Maybe you're trying to decide about an animal and how much space an animal needs. Maybe you're designing a room and how much space there is between furniture. Or maybe you're designing an event or a theme park or a garden and you need to decide where things are going to be located. That is the purpose of area. Now we're going to look at ways to find area. Sometimes we're lucky enough for a shape to have a grid. That grid helps us to decide how many squares there are within it. This grid up here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 squares in it. Now you also might have noticed that I have 3 rows of 5. Now if I told you this lower square also had 3 rows of 5, would you believe me? They look close to the same size. Another way I can go about solving this is just multiplying. I have 3 sets of 5. I could add 5 plus 5 plus 5. Hopefully you remember that repeated addition also gives us multiplication. So 3 times 5 equals 15. That's the same number we got up above. Let's move on to exploring some problems together. So I want to know here, what is the area of this shape? Now, before you go up to the screen and you start counting all those individual boxes, I'm going to help you figure out the side lengths. So I'm going to take my marker and I'm going to mark our boxes so that way I remember which box I'm on. So I have 1, 2, 3, 4, 5, 6. So my top is 6 and my sides are 1, 2, 3, 4, 5. Take a minute and figure out what is the area of this shape. Some of you will be doing repeated addition and take 6 plus 6 plus 6 plus 6 plus 6. My hope is that you're able to look at that repeated addition and remember that that's multiplication. I have 6 groups of 5. So I have 5, 10, 15, 20, 25, 30. 6 times 5 is 30. Now to double check my work, I could go back through and I could count all those boxes. Or I could skip count. I know that there's 6 in this row. So I have 6, 12, 18, 24, and 30. That gives me a total of 30 square units. Now, when I deal with area, it's important that we label it. So let's say that these are centimeters. I'm going to say that this is 30 centimeters squared. Now, this little 2 up in the corner just means squared. It's one of those fancy math terms that it's important that we start remembering goes with area. Now, this shape is a little bit more challenging. Notice that it's about the same width, but it's a little bit longer. Now, the problem with this shape is that I don't know what size units I'm going to use. Am I going to be working with inches? Am I going to be working with feet? Am I going to be working with really big measurements like meters or yards or miles? Now, that's kind of a difficult one to figure out. So I'm just going to give you the label, and I'm going to say that we are 6 inches wide, and we are 9 inches tall. Go ahead and take a minute and see if you can figure out what is the area of a rectangle that is 6 inches wide by 9 inches tall. Now I cleared off my work area next door, and I want to show you, and I want to prove to you that this is 6 by 9. Now I don't want you to count those squares individually because that can be a big challenge. I want us to think about what do we know. We know that a 6 is made up of 5 and 1. So if I take this last column over here and I break it apart, I have now, rather than 6, I have 5 over here and 1 over here. So I can look at this area as a 5 by 9 and a 1 by 9. That might be a little bit easier for you to think about if you don't know 6 times 9. Okay, now that you had a minute to think about that, what do you think 5 times 9 is? 5 times 9 is 45, and any number times 1 is 9. Or is itself, sorry. So 1 times 9 is 9. 45 plus 9 is, if you said the area was 54, you're correct. But it's important that we remember those labels. So again, we're working with inches. And remember that little trick I just reminded us of. I have to show that I'm squares because I'm talking about how many little squares there are that cover a flat surface. So the area of this shape is 64 inches squared. Now I told you we were going to start doing some irregular shapes. Notice that the shape next door is not a quadrilateral. It doesn't have 4 sides. Instead, this shape has 6 sides. But I'm still dealing with squares, luckily. So I want us to look at how can I see this as 2 smaller quadrilaterals. I can see that first big side as a long rectangle that has 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 9 is that first segment. Now, some of you know 3 times 9 already, and that's okay. If you don't, that's also okay. 3 times 9 equals what? If you said 27, you're correct. Now, my problem is that I need to add on this smaller section that's next door. So this smaller section that's next door is a different size. It is not 3 by 9. I do have 3 on this side, but I'm only 4 units tall. So this section is a 3 by 4. Now what's 3 groups of 4? Let's skip count. 3, 6, 9, 12. You could also skip count by 4s. 4, 8, 12. That side is 12. So what is the overall area when I add 27 plus 12? Well, let's start in my ones. 7 plus 2. That is 9. Great job. Now I need to move next door to my 10s. I have 20 and 10. 20 plus 10 more is 39. What's wrong with this answer of area? If you said this answer of area is wrong because it's missing the units, you're correct. I need to label it and say I have 39 inches squared. Great job. Let's try out one more irregular shape. So this one's a little bit different, and I want you to think about how can I cut this shape into other smaller quadrilaterals to deal with. Now, I'm on a hunt. I'm looking for quadrilaterals. Where could I cut it? I could cut it straight across here in the middle. If I cut it there in the middle, I have one big rectangle on top and I have 2 smaller sections on the bottom. If I erase this line, where's another spot I could cut it? Exactly, I could cut these 2 down, so then this is another rectangle in the middle. So I'd have 2 long ones and a short one there in the middle. Now, there's one other way to solve it, and this one's a little bit more challenging. So if you saw those first 2 really easy, awesome work. I want you to think about this big rectangle. If this was a piece of cake and you woke up and your birthday cake is missing some of this section, and I wanted to know how much was missing, how much went away and was cut out, I could do that too. I could figure out the total area of the big rectangle and subtract out this middle section. So to review, when you do this, you have those 2 long ones and the short one in the middle, or you have that big one on top with the 2 short ones on the sides. I want you to pick one of those 3 methods, and I want you to try solving this one. Now, for those of you that are a little stuck, that's okay. I'm going to walk you through how to solve this one, while others are going to go ahead and keep working. So looking at this shape right here, I see that my green and my blue sides are exactly the same. They both have 2 at the bottom, and they both are 5 tall. So when I write out that equation, I'm going to have 2 times 5 plus 2 times 5. And then I have that top part that's red. And I see that it's 4 tall, and this one is 6 wide. 1, 2, 3, 4, 5, 6. So that last one is going to be 4 times 6. Now 2 times 5, what's that? That is 10. So I have 10 plus 10. Now I have 4 times 6. I want us to think about those 6s. We just worked with them. I have 6, 12, 18, 24. Great job. So I have 10 plus 10 plus 24. Now if I start in my 1s, I have 0 plus 4. Then if I look at my 10s, I have 20 plus 10 plus 10. So I have 40. So I have 40 10s and 4 1s. So I have 44 altogether. Now the other way we can do this is we can start at 24 and count on by 10s. 24, 34, 44. Now what's missing from this answer? If you said your units, you're correct. 44 inches squared. Now, for those of you that took that challenge and did the big square and subtracted out that middle part, let's look at that. So I'm going to draw a line, so I'm going to do that down below. So it's still 6 wide. And I remember I need to figure out that big square first. So I have 4, 5, 6, 7, 8, 9. So I have a 6 by 9. And I took out, I'm going to subtract, because I took out that middle section, 2 by 5. Now the problem before, we had that 6 times 9 equaled 54. And if I take away 2 times 10, which equals, or 2 times 5, which equals 10, I do still end up with 44. That's a great way to check your work and see, did I do my math correctly? As good mathematicians, we're going to make mistakes, and that's okay. But what's important about mistakes is that we go back and we look at them, we inspect them, we correct them, and we respect them. It's okay. We can move on from a mistake, and we know that the next time we've learned something. So let's go ahead and wrap up for today. The final question I wanted to leave you with today was, can more than one shape have the same area? Below I've included a rectangle that has 4 rows of 6. 4 groups of 6 equals 24. Is there any other shapes that you can think of that would have an area of 24? Some of you may have thought of a 2 by 12. That would give us 24. Maybe you thought of a 3 by 8 or a 1 by 24. Any of those options work. We also have irregular shapes that can get us there as well. So think outside of the box when you're working with area. It doesn't always have to be a perfect square or rectangle. I've enjoyed exploring mathematics and area with each one of you today. If you're looking for other activities to continue your exploration of math, feel free to check out Spokane Public Schools Learning at Home webpage. If you've missed any of our previous lessons on any grade, go ahead and head to KSPS's website and you can check out all of our previous videos there. Have a great day of learning.